Hello and welcome to Putting Your Head in the Cloud, Microsoft Azure for the SQL Server DBA. My name is David Postlethwaite. I'm a database administrator for a large financial services company on the south coast of England. I've been working as a DBA for the last 8 years and I currently manage both SQL and Oracle instances. Previous to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle, and way back in time I was a Windows and a NetWare administrator. I'm an occasional contributor to the blog on gethinellis.com, and if you wish to contact me, my details are on the screen. Now, Microsoft Azure SQL Database has grown significantly since I started speaking on Azure 3 to 4 years ago. It's just not possible to cover everything and keep this video to a reasonable length. Instead, I'll introduce a number of features of Azure SQL Database, but won't demonstrate them all in this video. Instead, I've produced short videos on my YouTube channel of the different subjects so you can watch the demos that you're interested in more manageable, shorter chunks. I've also produced a free ebook. I've just updated it in May 2018 to the 4th edition to cover many of the changes that have occurred in the last year. It's over 100 pages long and covers everything that I'll mention. There's the source code for all the demos that I do and those that I don't do. And you can get this for free by signing up on gethinellis.com. This talk is aimed at those who have yet to look at Azure and those who want to find out more about the options there are for Azure SQL Database. We'll start with a quick revision of the cloud service models, IaaS, SaaS and PaaS. Take a look at where Microsoft Azure is based around the world and the services that it has to offer. Then we'll log into the portal, take a look at Azure and start creating databases. We'll then get stuck into some of the technical stuff with Azure SQL Database. And finally, we'll ask the question, do you require a DBA with Microsoft Azure? Now, there are 3 main service models in the cloud, and you will see these buzzwords being used a lot in cloud discussions. And these are Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, SaaS. To get a better understanding of what these mean, take a look at this diagram, which shows the typical layers of an IT solution, starting at networking through storage, the servers, virtualization, up through the database layer, finally to the application. Now think of infrastructure as a service as hardware to rent. Instead of purchasing network equipment, storage space or servers, you use the cloud provider's infrastructure. This means the cloud provider owns and maintains the housing, running and maintaining of all the hardware, not you. You will need to install the operating system, the database software, but you don't have to worry about maintaining the hardware, and the cloud provider will have mechanisms in place to ensure that your hardware continues to work in the event of a failure. Typically, this will be a virtual machine where the cloud provider supplies a server with your chosen operating system installed, ready for you to install your copy of SQL Server. But you will be responsible for all the patching and upgrading of the software, but you don't have to worry about the underlying hardware. Platform as a Service can be thought of as servers to rent. Here the cloud provider supplies you with the hardware, the operating system and the database server. Typically you'll create a virtual database and then simply connect to it and start creating the tables and views and procedures. You don't have to worry about software installation, patching, upgrades, failover and backups. The cloud provider will manage all of that for you, and this is the simplest way to create a database in the cloud. Now, with both IaaS and PaaS, you have the flexibility to use more or less storage or processing power as and when you require it, and this is attractive to business which might otherwise have to maintain large amounts of storage or CPU just for occasional peaks. With software as a service, we go the whole way and simply rent applications over the internet from the vendor. We don't have to worry about hardware, operating systems or software maintenance. This would be things like Office 365, Skype or Photoshop Online. In fact, any application you don't have to install on your laptop could be considered software as a service. As well as removing the need to buy, install and manage software on your computer, it also has the advantage of the software being accessible from anywhere and usually on any device with an internet connection. Now, the term as a service has become very popular, so you'll often hear vendors using it to describe their service, such as storage as a service, or disk as a service, or database as a service. I've even seen a consultant advertising himself as DBA as a service, where you can rent his expertise over the internet by the hour. So let's take a look at the Microsoft Cloud offering. Originally called Windows Azure, it was renamed in March 2014 to Microsoft Azure to reflect Microsoft now offering more than just Windows-based services. Microsoft has divided the world into regions. There are currently 50 regions with more due to come online. Not every data center offers every Azure service, and you'll see that some of the data centers are for US government use only. You can choose to place your cloud services in any data center in the world, but putting your data or your applications on the other side of the world may affect your customers' performance if they're all based in Europe. Your data held outside the US is safe from the US government. Microsoft won a court case a couple of years ago where the US government wanted some emails held in the island data center, but Microsoft argued successfully that although they are on servers owned by a US company, they were outside US jurisdiction. You'll see that there are no live data centers in Africa. When South Africa was allowed to start using Azure a couple of years ago, their nearest data center was so far away that performance was unusable. As you can see, there are now 2 data centers being built in South Africa, which should help them. When I started speaking on Azure, there were just 2 data centers in Europe, North Europe in Dublin in Ireland, and West Europe in Amsterdam, the Netherlands, even though Dublin is further west than Amsterdam. There are now 12 regions in Europe, 2 in the UK, 2 in Germany, 2 in France, and soon to come online, 2 in Switzerland and 2 more in Germany. You'll see that the data centers come in pairs. Each data center has a partner, which is where the backups for DR are sent to. Azure offers us more than just databases and virtual servers. In fact, everything you would ever want to do in your own data center is now available in Azure. And I seem to be constantly getting emails about new features in private preview. We have our SQL database, and that's what we will be concentrating on for this video. We have Azure SQL Data Warehouse, a highly scalable DBMS for data warehousing workloads built on a massively parallel processing architecture. Azure Data Lake allows us to store relational and non-relational data of any size and shape for all types of processing and analytics. Azure Data Factory gives us our SSIS type functionality. Azure Virtual Machines, this is the infrastructure as a service where we can build virtual machines not just with Windows but other operating systems like Linux. We can build websites, mobile apps and APIs with the app service. We have storage, just like OneDrive and Google Drive, but as well as blob and file storage, we also have table and queue storage. Artificial intelligence has become a very popular topic in the last year. Here we can create our machine learning apps. We can join our company Active Directory to Azure to allow single sign-on and streamline our security. And we also have ways to automate and schedule tasks in Azure. So that's just a few of the services available to us, but there is a whole load more, as you can see on that screen. So let's log into Microsoft Azure and take a look. The URL for Azure is azure.microsoft.com. If you have an MSDN subscription, then you have between 45 and 100 euros per month credit on Azure. If you use up all your credit, then your account will be disabled for the rest of the month unless you choose to pay for it. If you don't have an MSDN account, you can create a trial account which you can try for a month. At the end of the month, your account will be disabled, or you can choose to start paying. So here is the main website for Microsoft Azure. You'll see that there is plenty of information to help you get started with Azure. If you scroll down, you can see the regions screen that we've seen before. Lots of information to encourage you to use it. At the very bottom, some very useful stuff here. We have webinars that you can watch to learn more about Azure, Azure Fridays, where you can listen to Azure engineers talking about some of the new features and how to use them. And there's also a blog here which allows you to keep up to date with what is going on with Microsoft Azure. We're going to click on the portal, and this will log us in to the Azure portal. This is the Azure Management Portal, and this is where you manage and create all the different Azure services. This is the new portal, which went live in December 2015 and uses a mixture of tiles and blades, and it has certainly improved since it first came out. The old or classic portal was removed in 2017, but you may still see documentation and videos using the old portal. On the left here we have a list of all the services which I use. If I click on all services here, this gives you a list of all the services that you can use within Azure. The ones with the yellow star are the ones which are on my menu. As you can see, there are lots and lots and lots of services. If anyone ever tells you that they know everything about Azure, I think it would be fair to say that they're probably not telling the truth. Now we're going to concentrate today on Azure SQL Database, so I'm going to come over here and click on SQL Databases. Azure SQL Database is an example of platform as a service. We don't have to build a Windows server or install SQL software or configure a SQL instance. We don't have to worry about software upgrades or disk configuration. Microsoft have done all of that for us. Azure SQL Database simply provides us with a platform where we can place our data. Once we've created a database, we can connect to it from our PC using Management Studio, or connect our application to the database using ADO, ODBC, PHP, or JDBC. With Azure SQL Database, all we have to do is create tables, views, and procedures that go into the database. The management of the database is all taken care of for us. So here is a list of the databases that I already have running in my Azure accounts. To create a new database, I simply click on Add. And now I need to type in the information necessary. We need to give the database a name, so let me call it My Database 1. You need to choose a subscription if you have more than one subscription that you wish your database to go in. I'm going to stick with my MSDN subscription. We then need to choose a resource group. A resource group is a logical container for grouping related resources together. The resource group could include all the resources for maybe an application, or maybe for a particular project, a particular department. If you were a reseller, you might group all of the resources for a particular company in one resource group, and then you can use that resource group for billing purposes. Now I'm going to select a resource group that already exists. I'm going to use the default SQL North Europe resource group. We now need to select our database. We can create a blank database. We could create one which contains the Adventure Works database, or we can create one from a backup of one of the databases that already exists. But I'm going to stick with blank database. We now need to choose the SQL Server that we wish our database to go on. Now in Azure, a SQL Server is completely different to what you're used to in your traditional SQL Server. The Azure SQL Server is simply a container to place your databases. There is very little that you can configure beyond the name of the server, its location, i.e. the data center it is in, and the system administrator account. At one time, you couldn't even name your Azure SQL Server. Microsoft assigned a random name for you, which is why I have some servers with some unusual names. So I'm going to select my server that already exists, called QEDZ SW in North Europe. We're now being asked, do we want to use an elastic pool? I will talk more about elastic pools later, but we'll leave that as not now. We now need to decide the pricing tier that we wish to have for our database. We're going to talk a bit more about pricing tiers in a moment. For the moment, I'm just going to stick with a basic level database, which will cost me £3.72 a month and allow me to create a database of up to 2 gigabytes in size. So if I click apply, and finally we have to choose our collation. Unfortunately, there isn't a drop down for the collation, which you are used to if you're using Management Studio. You will probably need to copy and paste the exact collation name from somewhere else to get it exactly correct. Once we've filled in all the information we need, we simply click on Create, and the database will now be created. And here we can now see the message saying deployment completed. If I refresh the screen, we'll see we now have a database called My Database 1. It's online in North Europe, and it's on my server called QEDZ, running in the basic pricing tier. If I click on My Database 1, we'll get to the main screen for our database. Now that we've created our database, we can connect to it using Management Studio. We can start creating our tables, our procedures, and our views ready for our data. Before we can connect to it in Management Studio, we need to do two things. First of all, we need to find out the connection string that we need. In your office, when you connect to a SQL Server, you probably just type in the name of the Windows server that the SQL Server is running on, possibly with the named instance at the end of it. Because our Azure database is on the internet, our connection string is going to be slightly different. And Microsoft have conveniently provided us a link to our connection strings. So if I click here, you'll see that we have connection strings not just for ADO.NET, but JDBC, ODBC, and PHP. Now if I zoom in, the bit that we're interested in for Management Studio is this bit here. The name of our server, .database.windows.net, 1433. If you're building an application, then you'll probably need all these different parameters as well. But this is the bit that we're going to need for Management Studio. One final thing that we need to do when you build a new Azure SQL Server or SQL database, initially no one and nothing can connect to it. We need to configure the database to allow connections to it. So if I click on My Database again, we can come up here and click on Set Firewall Rules. Here we can enter the IP address range that we want to allow through to our Azure SQL Server. We can give it a name and an IP, a starting IP and an end IP address, and then we can save it. Conveniently, the screen shows us what our client IP address is, and we can simply click on Add Client IP to add it to the list, and then we can click Save. And now that IP address can access the Azure SQL database. Also, by default, other Azure services cannot connect to your database. You need to enable this option called Allow Access to Azure Services to allow other services, maybe automation accounts or websites, to be able to connect to your Azure SQL Server. So it's important that you turn that on if you wish that to work. Now that we've configured our firewall, we can now connect to our Azure SQL Server. So let me come over to Management Studio. Let me click on Connect and Database Engine. I already have the name here. So you can see I have QEDZ.database.windows.net, 1433. And we're using SQL Server authentication. Now I'm going to type in my Azure admin account name, followed by the password. I just need to check one option over here and remove AdventureWorks 2012 as the default database. Come back to the login screen, click Connect, and that will now connect. And we have successfully connected to our Azure SQL Server. If I click on the database link, you'll see that I have my AdventureWorks 2012 database on this server, as well as the new database we just created called My Database 1. The first thing you're going to notice is that the options available for an Azure SQL Server are rather shorter than what you're used to for a traditional SQL. If I open up the connection to my SQL Server running on my laptop, you'll see that Azure only offers us the database and security option. We don't get server options, replication, always on, integration services, and specifically we do not get SQL Server Agent. You have to remember that Azure SQL Database is just a database as a service. All we are getting is a database. All the extras that we're used to with a traditional SQL Server are not included in the database. You'll also find that the GUI for Azure SQL Databases is not complete compared to your traditional SQL Server. So if I come down to security and look at logins, if I right click and say new login, rather than getting the GUI, I'll get just the create login T-SQL script, which I will then have to change and manage. Management Studio 2017 has definitely improved the GUI side. If you're using older versions of Management Studio, you may find that there is less GUI support in the database section as well. So let's open up a query that I have. Let me log in again. Check that I'm logging into default. I don't have a default database. And let's run a few commands against our Azure SQL database. So let's start off with at version. What do we get back? You'll find that we actually get back that it's Microsoft SQL Azure version 12, built on May the 4th, 2018. The version numbers of Azure don't follow exactly the version numbers of your traditional SQL Server, but Microsoft Azure is fully 2017 compatible. If I select some properties of our server, you'll see again product version of 2012, product level of RTM, and the edition is actually SQL Azure. You do not get standard or enterprise, it's actually SQL Azure. If we want to create a database, we can do it using T-SQL. It's very simple. We just say create database DB1, and that will create for us a blank standard S0 database. And this normally takes a couple of minutes. If we want the full syntax for an Azure SQL database, it's simply create database and its name, the collation you wish to use, the maximum size, the addition, and the service objective. You don't have to specify any files, any file growth, file groups, or recovery model. That is all done for you. The only bit that matters is the performance tier you wish to use and the collation. And that took 50 seconds to create the database. Now, one thing that you're going to have to get used to with Azure is the fact that the use command does not work. So if I say use DB1 and execute that, we actually get an error message back saying use statement is not supported to switch between databases. The only way you can change between databases is to use the drop down screen to select DB1. And once you've selected a user database, the drop down doesn't seem to work. Still in Management Studio 2017, if you want to change to a different user database, you'll have to type the name into that box. So if we select properties of our database, you'll see that it comes back and shows us that it's a standard edition database. We can easily change that edition to basic just by running the alter database command, and that will take a few moments. If I run that command again, you'll see that it still comes back as standard. It will take a little while and we can lose our connection whilst it's doing that. So let's run it again, and it's returned to basic, and this time we've been lucky and not lost our connection. So if we run this command to have a look at some of the properties of our database, you'll see that it's called DB1. It's online, you can't take it offline, it's always online. The recovery model is full, it's always full. Any database built now It has a compatibility level of 140, which is SQL Server 2017. There's the collation we chose. It's always in multi-user mode, you can't change that. Interestingly, it's in snapshot isolation mode, which is different to your traditional SQL Server. So do be careful on that. And to drop the database, if we want to, it's simply drop database db1. So that gives you a flavour of how to run commands and build SQL. Let us now go back to PowerPoint and we'll carry on with some other information. The server roles are not the same as those found in a traditional SQL Server. In fact, there are only 3 server level roles. We have one called the server level principal account, and this is equivalent to SA, but it can't be called SA, and the account is created when you first create your Azure SQL Server. We then have the login manager role, and this is like the security admin role for an on-premises SQL Server, and the login manager role can create logins, and that's it. We have the DB manager role, and this is similar to the DB creator role on an on-premises SQL Server, and this role is allowed to create new databases on that Azure SQL Server. And that is all we have, because all the other roles that you're used to seeing in a traditional SQL Server are for features which are not available within Azure SQL Database. Originally, Azure SQL Database only supported SQL logins, and these work exactly the same way as SQL logins in a traditional SQL Server. Your Azure SQL Database has the same roles as a traditional SQL database, so nothing has changed there. Now, Azure SQL Database is actually a contained database. Contained databases were introduced in SQL Server 2012 and allows a SQL database to be independent from the SQL Server. So with a contained database, you no longer need the server level login. You can create a user at the database level with its own password. The example code is shown on the screen. Microsoft actually recommend using contained users to avoid having to interact with the master database, which could be on a completely different physical server to your user databases during login. And if you do use contained users, you can use database firewall rules rather than server firewall rules to control access to your database. We can also use Azure Active Directory logins to log into an Azure SQL database. As I've already mentioned, you can connect your own Active Directory domain to Azure, but Azure will also assign you a system-defined Active Directory as well. So you will end up with a name a bit like mine, clooney.webco.onmicrosoft.com. You can create Active Directory logins in the portal, and you can assign one of those logins as the Active Directory admin to your Azure SQL Server. You can then log into Azure Database using that Active Directory admin, and then you can add other Active Directory users to the database. The syntax is slightly different, so we have to say can create user, the username from external provider. But you must be logged in as an Active Directory login to be able to create new Active Directory users. As you can see on the screen, when you come to log in to an Azure SQL Server using Active Directory, there is an option called Active Directory Password, where you can put in your Active Directory account and the password, which is slightly different to what you're used to with your integrated security in your local SQL server. Now, Azure SQL Database doesn't support every feature that you would find in a traditional SQL Server, and you should be aware of this when you're designing a database for Azure. Version 12 of Azure SQL Database provides very close compatibility to SQL 2017 than the previous version 11. Most T-SQL statements are fully supported, such as most data types, operators, string, arithmetic, logical cursor functions, and other T-SQL elements that most applications depend on. Partially or unsupported functions are usually around server level activities such as files, high availability and security features, or for special purpose features such as service broker. There is a link on the screen which will take you to the most up-to-date list of unsupported features. So do check that out if you want to be up to date. So let's talk a bit more about Azure service tiers. There are 3 performance levels for Azure SQL Database: Basic, Standard and Premium. And each service tier has several different power levels within it. and these are measured in something called database transaction units, or DTUs. Now, DTU represents the power of the database engine as a mixture of CPU, memory, read and write rates. Unlike your traditional SQL Server, you cannot choose the number of CPUs, memory, or disk configuration. And the reason for this different power rating is, I suspect, to avoid people trying to do a direct comparison of their on-site server performance with that of Azure. We have Basic, which is suited for small-sized databases with very few connections. We have Standard, which is probably best for the majority of workgroup and web applications. And then we have Premium, which is designed for high transactional volumes, lots of users, and lots of data. Here is a table offering what each tier offers, and this is changing and improving every time. So we can start with a basic database, 2 gigabytes of disk space with 5 DTUs, and that will cost €4 a month. And we can go right up to Premium 15, which will allow us to have a 4 terabyte database, 4,000 DTUs, but that's going to cost us €13,000 a month. The DTU number allows you to see the relative power of the different performance levels. So Basic has 5 DTUs, so you can expect S1, which is 20 DTUs, to give you 4 times the power of Basic. P1 is 12.5 times more powerful than S0. You decide on the power level you think you require, and then you monitor and tune the database as required. As we've seen, it's very easy to change from one tier to another if you decide you need more or less power. But remember, the power is set at the database level and not at the underlying server. The server is just a repository to contain your databases, and that is all. But things are changing. In the last month, Microsoft have released 2 new service tiers that allow you to choose the number of CPUs and memory instead of using this DTU model, and these are called vCore General and vCore Business Critical. You can choose between 1 and 16 cores, which will give you between 7 gig and 112 gigabytes of memory. These are still in preview, and they're not cheap. A 1-course database will cost you a minimum of £150 a month. You'll also notice that you require SQL Server licenses, which the DTU model doesn't require. If you have a SQL Server license with software assurance, then the price is reduced. If you want to find out more about the limits and the resources that are used by the vCore, there is a link on the screen. Since this is in preview and I haven't had an opportunity to review the vCore model, the information in this talk will be about the DTU model, which is probably still where a lot of people will be using Azure SQL Database. Now, with Azure SQL Database, managing backups and high availability, such as mirroring and replication, is all taken care for you. Backups are automatically created for every active database. Full database backups once a week. Differential database backups are created once a day. Transaction log backups every 5 to 10 minutes depending on activity. The full and differential backups are copied to the partner region to ensure availability of the backups in the event of a disaster in the primary data center. Additionally, it maintains multiple copies of the database in different physical locations in the primary data center to mitigate outages due to hardware failure. Any one time there are 3 database replicas running, 1 primary replica and 2 secondary replicas. Data is written to the primary and 1 secondary synchronously, and to the second replica asynchronously. If the hardware fails on the primary replica, the database fails over to the second replica seamlessly. In case of a physical loss of a replica, a new replica is automatically created. So there are always, at a minimum, 2 physical, transactionally consistent copies of your data in the data center. And you don't have to do anything to manage that. It's all done for you. You can also set up your own replication to another data center, and this is called geo-replication. Here you can have asynchronous replicas of the primary database in another region. You can have up to 4 read-only secondaries in any Azure region. but you will pay extra for these extra databases. You can break the replication or manually fail over at any time, and the replica will become an online database. So you can see that log shipping, mirroring, and always-on type functions can be added with little effort. In the event you need to restore a database, it can be done from the management portal. Basic, Standard, and Premium all offer point-in-time restore, but you cannot overwrite an existing database. You can only restore to a new database with a new name on the same server. And be warned, backups are only kept for a certain period depending on your service level. So Basic is only kept for 7 days, Standard and Premium for 35 days. Also note, you cannot access these backup files to download and store anywhere else. If you need to keep backups for longer periods, then you will have to create your own backups either manually or using an automation task to your storage account. You can then keep those in the storage account or copy them down to your own data center. But naturally, you'll pay for the storage you use and for the I/O in copying it down. There is a new service currently in preview that will allow you to keep backups for 10 years, and this can be found on the service screen. Now, one of the major concerns over using the cloud to hold your data is security. You are in effect putting your data on a server that is being shared with possibly hundreds of other people. Microsoft have obviously put in place mechanisms and procedures to ensure your data systems stay isolated from anyone else in Azure, but what options do you have to keep your data secure from potential attack? We've already discussed firewall security. So by default, you cannot connect to an Azure SQL Server. You must give access to an IP address or an IP address range that you want to have access to the database. But we can also do this in T-SQL, and with T-SQL we can not only create firewall rules at the server level, we can also create them at the database level, and the syntax is shown on the screen at the moment. If your IP address doesn't have access through the server level firewall rule, Azure will have a look at the database level firewall rule, and if you're in that group, you'll have access just to that database. So you can get much more granularity using the database level firewall rules. Let's go back to the management portal and have a look at some of the other options. For this, I'm going to use my AdventureWorks 2012 database. First thing, transparent data encryption is turned on for all databases. Transparent data encryption encrypts your data files with a certificate and a password, so that if someone was actually able to get hold of the data files and try to restore or attach them to another SQL server, they would not be able to use them without having a copy of the certificate and knowing the password. At the moment, Azure stores the certificate and the password within itself. There is a new option coming soon where you'll be able to create your own certificates and store them in the Azure Certificate Store. We have an option up here called Auditing and Threat Detection. If we turn Auditing on, then Azure will audit every single connection to our database. If I click on the View Audit Log link here, you'll see we get a list of connections that we've had on our database. If we click on a particular one, we can see when it took place, the server, the database name, the application it came from, who logged in and the IP address they came from, and also the actual statement that was run. So we can quickly see who is connecting and what they are running on our database. Now these audit logs are stored in an Azure storage account. So you could then take them offline and analyze them using other software on your PC. We also have an option here called Threat Detection. Now if I turn this on, this can alert us to certain threats which are coming to our database. If I click over the information link here, it says Threat Detection detects anomalous database activities, including potential security threats to the database. Now there are several types of threat detection that it will look for. And these are SQL injection vulnerability, and anomalous client login, which basically means any unusual logins. If we enable this, we can then get any alerts sent to our administrator email accounts or any email account you wish. Threat detection costs $15 per server per month, so you need to decide whether you wish to pay that for that service. The next option down, vulnerability assessment. Here, Azure will analyze our Azure SQL Server and report back what it thinks is high, medium, or low risks. So here is a list of what it has found, the security check that it's run, which database it's looked at, and whether it considers it a high risk or not. So if I was to select one of these security checks, it will actually explain what it means, the actual query that it's run, and what it has found wrong. Now, if you decide that this is actually an acceptable level of risk, you can approve this as the baseline, and then the next time that you run your vulnerability assessment, it won't pick it up as being a high, medium, or low risk. So this can be very handy for examining databases for potential flaws, which you can then fix to make your database more secure. Now, if we scroll down the screen, we will get to the monitoring options, and we have one here called Alerts Classic. Here we can get Azure to email us when certain metrics go beyond or go below a certain value. I have 3 alerts created here. One called Hacking Attempt, which looks for any attempts to come through the firewall which are invalid. I also have a login error, so if there's any failed connections, I'll be emailed. And I also have one called Overutilized, so if the CPU percentage goes greater than 60%, then again it will alert me. So if I click on the Hacking Attempt alert, here we can edit the rule. Here we can give the rule a description. We can choose the metric. You can see here there is a huge number of metrics, from blocked by firewall, failed, successful connections, CPUs, percentages, deadlocks, IO percentages, database size, etc. Once we've chosen our metric, we can then choose our condition. Are we looking for a value greater than or less than? And then we can choose the threshold. So in this case, if I have one failed login attempt through the firewall in 10 minutes, then please email the owners, the contributors, and the readers, and I can add additional administrator emails as well. We also have an option here called webhook. If we create a webhook, this could then be used to trigger another event, a scheduled task of some kind. So for instance, with our overutilized option, if we set up an alert where the CPU was constantly running at 99%, then we could set up a webhook that could then run a task to automatically move our database up to the next database tier. We can also create our own dashboards, which we can place our own reports on. So if I come down here, I have a dashboard that I've already created called EventureWorks 2012. And here you can see that I have numerous graphs showing the activity that has been going on my server. So here's a graph for failed and successful connections, the CPU percentage, the IO, any blocked by firewall rules, and the like. We can also put our alert rules on here, so I can see that there are no active alerts at the moment, but I have 3 enabled alerts. It's very simple to create this. We just click on New or Edit. This will open up the tile gallery. We can then select the type that we want. In this case, if we go to the bottom, we have SQL databases, and then we have various graphs which we can simply drag onto the screen. Get rid of that one. So if I drag, say, database connections, I can place it here. I can now edit, and I can choose the time range from past hour, past week, whether we want a bar or a line graph, and then we can choose the different things that we wish to display. We can then click OK. If we want, we can resize it, and once we're happy, we can then say done customizing. And there we have our graph. Once we've created this, we can share this dashboard with other users of Azure. So if you're a senior DBA, you could create this and share it with your juniors so they can watch and check on the performance of your Azure SQL database. Now if we come back to SQL Database, for this next part I'm going to use my VentureWorks 2016 database, and I'm going to scroll down to the bottom, and under support and troubleshooting I have 5 options. I have resource health, performance overview, performance recommendation, and query performance insight, and finally automatic tuning. Now if I click on performance overview, we can see the top 5 queries by CPU consumption over the last 24 hours. And we can see here that there has been some activity. So if I drill down into this section, it will open up the query performance insight, where we can start seeing more information about what was happening at that point, and also the query IDs that were causing this particular bump in activity. I can now click on the query ID that I'm interested in looking at, and this will actually show me the actual query that was being run and further information about what was going on at the time. We have a button here which will show us the recommendations. There aren't any recommendations at the moment. How we could improve this query to make it run better, maybe add new indexes and the like. That is these options joined together, but we also have an option here called automatic tuning, and this uses similar technology to the query store, which is now available in SQL 2016 and 2017. Here we can allow the Azure SQL database to use artificial intelligence to work out whether it is worth creating new indexes or dropping indexes that aren't required, or using the forced plan option to not use the current execution plan but use a previous execution plan for that query, which will give better and faster results. You can choose to turn these on, and Azure SQL Database will start self-tuning. Now a lot of people will look at that and go, whoa, I'm not sure whether I want my SQL database to start dropping and creating indexes and changing execution plans. Having read a little bit about it, it seems that it can actually make quite a bit of difference to your database, so it might be something worth considering. If it does create or drop an index, it does carry on monitoring to see if it has made an improvement. If things have actually got worse, it will put the index back in again, or drop the index depending on what it's been up to. But it does look like that could be a very handy option. Now you'll remember with Azure SQL Database there's no SQL Agent, so you can't create scheduled agent jobs within an Azure SQL Database. You must remember that Azure SQL Database is an example of database as a service, so only offers the features of a database, i.e. somewhere to place your tables and data. So what options do we have to run scheduled tasks against an Azure SQL database? Well, first of all, we could create a linked server from our on-premises SQL Server to an Azure SQL database. It does take a few extra hops. You actually have to create an ODBC DSN that connects to your Azure SQL Server, and then you create that linked server to that ODBC DSN. But then it would be possible to run agent jobs on your local SQL Server that ran queries and procedures on your Azure SQL database. Azure Automation is probably the best option for creating scheduled jobs. Azure Automation uses PowerShell to run scheduled tasks. It can be used not just for SQL, but to automate just about anything within Azure. I actually use an automation task to shut down a virtual machine at 10 o'clock at night and restart it again at 9 AM in the morning, because I don't need that server when I'm asleep, and that has cut the cost of running that server by half. There are plenty of examples to get you started within the portal, and there are example PowerShell runbooks in my ebook and also videos on YouTube. We also have something called the Azure Scheduler, and this allows you to run tasks against HTTP endpoints. So you can use this to call a web page. I've actually used this in one of my projects where I have a website with web pages which, when they run, will run tasks against an Azure SQL database. I created a scheduler job that ran that page, and that then processed the SQL Server. It's worked pretty well, but you can hit timeout issues if the web page takes a long time to run. But in my experience, once the web page is kicked off, that store procedure, it carries on running in the background. Now, trying to monitor and manage your SQL databases to ensure that each one is running at the right DTU could be quite a challenge if you have lots of databases. You can use alerts and automation to automatically move a database up and down the performance tiers, but a change to the DTU requires the database to be restarted, which can cause downtime. If you have a database with regular peaks in between low activity, constantly changing the DTU may be impractical. Let's take a look at an example of how elastic pools can benefit you. Here is a report of 3 different Azure databases. As you can see, each one peaks every 20 minutes, but between that peak, activity is pretty close to 0. With a standalone Azure database, we'll need to size each database to cope with the maximum peak, but we'll still have to pay for that performance level between those peaks when it's not needed. Now, if we merge these performance graphs, we can see in this case that the combined DTUs have not increased. In this case, if we could share the power, then all 3 databases could just run in the one DTU, rather than each database having to use its own DTU, costing us 3 times as much. By pooling the power available, we can use less DTUs overall to achieve the same performance, and this is what elastic pools give us. The shared resource in elastic pools are measured in elastic database units, or EDTUs, and a pool is given a set number of EDTUs for a set price. Within the elastic pool, individual databases can then auto-scale to gain or reduce DTUs as required. Under heavy load, a database can consume more EDTUs to meet demand, while databases under light loads can consume less. You can add DTUs or you can remove them from the pool with no database downtime and no impact on the databases in the pool. You can add or remove databases from the pool or limit the amount of DTUs a database can use under heavy load to reserve some EDTUs for other databases. It's not cheap. The minimum basic level elastic pool is £55 a month, so you would require something like 15 to 20 databases to make it worthwhile. Now, elastic pools are very good for sharded databases, where a large database is split into several smaller databases, either because the database has become larger than Azure will support, or to spread the power over several databases, thereby increasing the overall power available. But sharding is for a talk in its own right. In 2016, Microsoft added a scheduler to a SQL database called Elastic Database Jobs, and at the time of this recording of May 2018, it's still in preview. Microsoft say Elastic Database Jobs allow you to reliably execute T-SQL scripts that span multiple databases while automatically retrying and providing eventual completion guarantees. And what this means is that you can run native T-SQL scripts against an Azure SQL database. You don't need to write complex PowerShell or C# code, which you would need to do if you're going to use automation to run your scripts. More importantly, you can run the scripts against multiple databases in one go. This makes it very handy for sharded databases within your elastic pool, and it will continue to retry on each database until it completes or the timeout is reached. But Elastic Database Jobs are not limited to running on databases within the elastic pool. It can be set up to run against any Azure SQL database. The bad news is that the options within the portal are very, very limited. The good news is we can install and run Elastic Database Jobs using PowerShell from your desktop. And one of the features missing from Azure SQL Database is the ability to create linked servers. However, there is something similar called Azure SQL Database Elastic Query, and this allows you to run queries against another Azure SQL database or data warehouse. The name is a bit confusing. You might think you require an elastic pool to be able to run elastic query, but it's not the case. You can run elastic queries from any Azure SQL database to any other Azure SQL database. A major drawback is that it doesn't support updates. You can only do selects. Stretched Database is a new feature in SQL Server 2016. Stretched Database allows you to stretch or split an on-premises table into an Azure SQL database so that your most frequently accessed data is stored on premises while your less accessed, maybe historical data, is held in the cloud. The idea being that you can keep the most frequently accessed data in a smaller table on your local server close to the users and take advantage of cheap cloud storage to hold your less frequently accessed data. When you enable a table to stretch, the old data moves over to the Azure SQL database behind the scenes. When you need to run a query that accesses active and historical information in a stretched table, the database engine seamlessly queries both the on-premises database as well as Azure SQL database and returns the results as if they had come from a single source. But it is not cheap. Now, Azure Data Sync allows you to synchronize changes between an Azure SQL database and a local database or other Azure databases in a similar fashion, but much simpler to traditional replication. It can synchronize data between an Azure database and up to 50 other databases, either other Azure databases or on-premises database. You install a small service on your SQL Server that acts as a link between your local database and the Azure database. It's quite tricky to set up, but it does seem to work quite well. Azure SQL Database Managed Instance is a new capability of Azure SQL Database. This will offer near 100% compatibility with your on-premises SQL Server. Managed Instance will allow customers to pick up a SQL Server from on-premises and load it straight into Azure without having to make any changes. This looks a very interesting new feature. It is still in preview and it's very difficult to get access to at the moment. I have applied, but so far I haven't succeeded. For those that don't like the current Azure SQL database, this could be the option that you are looking for. Now, if you prefer more control over your SQL instance, or you prefer to have a SQL Server that looks like one in your office, then you can create a virtual server. A virtual server is an example of a infrastructure as a service. It's a very simple process. Click on you, select the server type from the list, press go, wait a few minutes, and you'll have a server ready to connect to. If you build a Windows server, you can use RDP from your desktop to connect to it, just as you would any virtual server in your own company. One advantage of virtual servers, as I've already mentioned, is that you can shut them down in the evening when you don't need them, restart them in the morning, and save money, which you cannot do with Azure SQL Database. Now, finally, do you require a DBA with Azure? With Azure, creating a database is as simple as clicking a button on a screen. Many of the DBA tasks, like backups, high availability, disaster recovery, and failover, have been taken care of. You might be thinking, is there anything left for a DBA to do? Well, yes, there is. The tedious tasks have been taken away, such as building SQL, checking backups, checking mirroring, checking always on is working. But bad design requiring more DTUs will now have a visible cost, whereas before the cost of adding an extra CPU or more memory to your local virtual server probably just got lost in the system and no one was ever charged for it. So DBAs will now be able to get on with the interesting stuff, being involved in the database design, tuning queries to keep the costs down, and you'll be able to demonstrate your value by the number of DTUs you've saved and thus the amount of money you have saved for your company. So I don't think at the moment we can say the DBA is going to die anytime soon. I'm a bit of a stickler on grammar and I cringe every time I hear someone who is talking about the cloud use the expression on-premise rather than on-premises. A premise is a proposition or assumption and has nothing to do with buildings. So please support me and use on-premises, not on-premise. So I hope this has been of use to you. Please let me know. Write to me, put a comment on the YouTube channel, and I hope you enjoy starting to use Azure to help you run your business better. So thank you very much for listening.